This podcast has to do with stoichiometry. It's a really long word, and I think you only will hear it in chemistry, but stoichiometry is using the mole ratio from a balanced equation using mole ratios from a balanced equation. Alright, so it has to be balanced in order to get the mole ratios. But using mole ratios to determine how much reactant is needed to make a certain amount of product. And it could be just the opposite of that. It could be to find out how much product, well, I guess how much reactant. You might have two reactants, so how much of one reactant is needed to fully react with the other reactant, but it has to do with, the main thing is using mole ratios. Alright, so if I just draw real quick, we'll do a pretty easy balanced equation. We're going to do this one, we've seen it before, but 2 hydrogens plus 1 oxygen, and I'm just going to have this unbalanced already, yields 2 waters. So now we have the micromole rockets. We've seen this equation, and we're going to see this equation throughout the entire year, really. So if we've said, maybe there's a question that said, in order to make 5.6 moles of water, how many moles of oxygen are needed? Alright, so we are wanting to change our units. Notice we're starting with moles of water, and we want to know how many moles of oxygen. Okay, so we're simply doing a unit conversion. And you've seen these many times before. This we're going to use our fence and rail, and again, just think of Pinocchio's friend, right, up on your shoulder. Let your units be your guide. Alright, so we're going to start with what we know, and in this case, what do we know? We know 5.6 moles of water. And then we're going to do our fence and rail. Alright, and moles of water is at top left, so it has to be on bottom right. Moles of water, because we want to get rid of moles of water. And we're going to change this into moles of oxygen. Okay? So, when we've done this before, when we did molar masses, what number always goes in front of moles? 1. Right now, do you see masses anywhere? And the answer should be, no, we don't. All we see is moles. Okay, so we're not dealing with molar mass, but we're dealing with a mole ratio. We're going to go from moles of one thing to moles of another thing. So where do we find this ratio? We find it from the balanced equation. So for moles of water, we're going to look up here and find what coefficient is in front of water. So it is a 2, so I'm going to put a 2 in the denominator. Similarly, I'm going to find moles of oxygen, and it has a coefficient of 1. So I can put 1 in the numerator. And again, moles of water is going to cancel out. I'm going to multiply across the top, and obviously I'm going to get 5.6, and I'm going to get moles of oxygen, because that's my only unit left. And I'm going to multiply across the bottom, and 1 times 2 is 2. And if I simplify that, we're going to find that our final answer is really 2.8 moles of oxygen. Alright, so that is kind of just an introduction to stoichiometry. You always use mole ratios, and we'll do one more example and come up with another equation. Let's see, how about potassium chlorate, so KClO3, yields, if we heat this, it's going to yield potassium chloride and oxygen. So we're going to put our lines out front. Notice K is balanced, Cl is balanced, O's are not. So in order to balance those, we need to have, or at least common multiple, a 2 in front of KClO3, and a 2 in front of KCl, and a 3 in front of oxygen. So this time our question might be, if, I don't even know, if, come up with a number, 11.2 moles of KClO3 react, how much oxygen is formed? Or we could say produced, because again, oxygen is a product, but something kind of like that. So again, we're going to start with what we know. And what do we know in this case? We know 11.2 moles of potassium chlorate. Right, we're going to draw our fence and rail. We're going to let our units be our guide. And notice moles of KClO3 is on top, so we have to put moles of KClO3 on bottom, so that they cancel out. We want to go to moles of O2. So in this case, as we look up at our balanced equation, moles of KClO3, it has what in front of it? It has a coefficient of 2. So we're going to put a 2 in front of KClO3. And moles of oxygen has a 3 in front of it. So we're going to put a 3 in front of moles of oxygen. Then we're going to do our math. And as we multiply across the top, notice we have moles of KClO3 as numerator denominator, so it's going to go bye-bye. And 11.2 times 3 is going to be 33.6 moles of oxygen. And when we multiply across the bottom, we have 1 times 2. So we just have 2, so we're going to divide that by 2, and we get 16.8 moles of O2. Alright? So that is stoichiometry, just an intro to it. Everything else we do the rest of this unit is going to be based on this, always using mole ratios to find out how much of one thing can produce something else in our equation.